Today we're going to talk about conditional statements as part of the expose into logical statements. A conditional statement has an if-then. And we see these all the time. If you do this, then you will get this. If you work all day, then you will get a paycheck. If you eat too many cookies, then you will have a stomachache. And so these if-then statements are called conditions because they have that condition on the front. And so when we look at this, if there are clouds in the sky, then it is going to rain. They have two parts, the if and the then. The hypothesis is the if part. And the conclusion is the then part. It's important to note, however, that when denoting the hypothesis and the conclusion, they do not actually include the if and the then. So the if and the then are separate, but the hypothesis is the part that is with the if. So the hypothesis in this case is there are clouds in the sky. The conclusion is it is going to rain. So the if part, but not the if, is the hypothesis. The then part, but not the then, is the conclusion. So the if and the then are separate from the statements themselves. So the hypothesis and the conclusion are both statements. In example 1, we're going to identify the hypothesis and the conclusion. And we're going to do that by underlining the hypothesis once and the conclusion twice. Very important to see how this works. In A, if a butterfly has a curved black line on its hind wing, then it is a viceroy. So the if part, remember, and the then, not too hard, but it's not the actual if itself. So the part with one line is a butterfly has a curved black line on its hind wing. That is the hypothesis. The conclusion is it is a viceroy. So in this case, if this condition is true, then this happens. In B, a number is an integer if it is a natural number. They've switched things around a little bit. So I'm noticing this if here. Remember, the hypothesis is the part that is with the if. So in this case, it doesn't come first, but it's still the condition. The hypothesis is that if part. And the conclusion that we draw, if that is true, is that a number is an integer. No then, but it's implied because the if is there. I want you to try letter C on your own. Remember, you're looking for those key pieces, that if. Look for that if part. All right, let's move on to example 2. We're going to use these statements to write a conditional statement. So we're going to have to use if and then. So those should appear in your statements. Letter A. The midpoint M of a segment bisects the segment. So there's a couple of different ways we can do this. We have to pick a part that's if. So if a point is a midpoint, then it bisects a segment. You could have written that a different way. You could have switched it around. If it bisects a segment, then it is a midpoint. But you need to have that if and then in there. So I've got my if and I've got my then. See if you can do letter B on your own. All of these are leading us to something that is evaluating whether these are true or not. So the if then could be true or not. If it rains cats and dogs, then we have a problem. That is true. But if you don't work all day, then people will pay you millions of dollars. That would be false. So we need to figure out what is true and what is not. In example 3, we're going to analyze the truth value, and we're going to tell if it's true or false. And if it's false, then we're going to provide a counterexample like we've done in the past. Look at number 1. If today is Sunday, then tomorrow is Monday. Does that logically follow? Today is Sunday. Could tomorrow be anything but Monday? Barring extreme circumstances, that has to be true. And so we don't need to provide a counterexample because it's true already. Letter B. If an angle is obtuse, then it has a measure of 100 degrees. Well, if it's obtuse, it doesn't necessarily mean that it's 100 degrees. If it measures 100 degrees, it is obtuse, but what if I had an angle that was 116 degrees? That's also obtuse, but it's not 100 degrees. So this statement's going to be false. I found the counterexample of 116. You could have said 139, 146.5. So not every obtuse angle measures 100 degrees. I want you to try C on your own. See if you can do that one. If an odd number is divisible by 2, then 8 is a perfect square. See what you think about that. See if you think it makes sense. Let's talk about negation. Negation is the process of making something a statement, not. It's easiest to show you how it works. If the statement is M is the midpoint of a segment, the negation would be M is not the midpoint of the segment. That's all there is to it. You add that not in there and you make it the negative. So if I say I'm wearing a necktie, the negation of that would be I am not wearing a necktie. It's pretty simple. There's a chart here that you need to memorize because it's going to tell us how to manipulate these statements and make them into different things. The conditional statement is that if-then. So for any conditional statement, we say it if-then. And the hypothesis of the conditional is denoted with a letter P. So that statement gets assigned that letter P. The conclusion is going to be Q. And so an if-then statement looks like this in symbols. And we read it if P, then Q. So the arrow is the then, the if-then. The converse is going to go then if in general. But we're going to leave the if and then where they are. So it's going to be Q to P. So it's going to be read if Q, then P. Inverse. We're going to make it negative. We're going to make it the opposite of the values. And so it's going to be not if, not then. It's going to look like this. Not P to not Q. And you'll notice that little thing here, this little tilde means not. It's going to be read if not P, then not Q. Contrapositive, we're going to make it negative and flip it. So it's going to be not then, not if. So the symbols look like this. Not Q, then not P. So if not Q, then not P. We need to write a couple to see how this works. Here is a conditional statement. if an insect is a butterfly, then it has 4 wings. So that's this one. It goes in the if-then. And so here's my hypothesis, and here's my conclusion. This is my P, and this is the Q. So if I'm going to write the converse, it's going to look like this. My if and my then stay where they are. And I switch the two clauses. So if it has 4 wings, so that's my Q, then P. Then an insect is a butterfly. So I just switched those two clauses. Inverse. So this is going to be that not P to not Q. So P and Q stay where they are. So if an insect is not a butterfly, then, and the second part becomes, if an insect is not a butterfly, then it does not have 4 wings. And so that simply making it a negation makes it the inverse. That's all it is. Now, it may not be true, but it's the inverse. Contrapositive. I'm going to abbreviate it CP. We negate both clauses and we switch them. So, remember, not Q, then not P. So, if it does not have 4 wings, then an insect is not a butterfly. So, to review, I have P, then Q. In the converse, I have Q here, then P. Inverse, not P, not Q. Contrapositive, not Q, and not P. That's all there is to it. If you memorize that chart, it's simply making them negative and switching them. All right, that's logical statements in a nutshell. We'll see you next time.